Hi everybody. In the previous lesson, previously on Lost, right? In Lost, and we covered the how we would go about determining or computing Lyapunov function, right? And we basically put some constraints, or there are some constraints where positivity of the Lyapunov function and the negativity of the v dot, right? And time derivative of the Lyapunov function. We just impose these constraints and we parameterized Lyapunov function, and basically we just covered how you would compute Lyapunov function, and we show how you would select some basis functions like first order, second order, etc., right? And then we covered how you would show or use SOS methods, and then in the previous lesson, linear programming, right? Linear programming is another technique of computing Lyapunov functions. And in that lecture, I am going to show how you would simulate nonlinear dynamical system. Just this is easy stuff, right? And then, the more importantly, we are just going to simulate for a bunch of different initial conditions in state space, right? And we again sampled those initial. We will sample those initial conditions, like where was it? Yeah, that. Remember that function? We just used that function in the previous, and this is. Let me just show it to you. It's like 4 lines, right? Four lines code, and we will use that function to simulate, no, sample from the inside of a ball, right? And without further ado, let's, okay, just run this, and please ignore this, section, okay? All right, and okay, we just started from scratch, right? And okay, this is t span, right? Starting from 0, and you may not use that if you don't assign any dt, right? Incremental time duration. The MATLAB will automatically use or compute some optimal, quote unquote, optimal uh, incremental value, right? And that will be variable this dt as well. And for that, I just assign this, right? And for 10 seconds, you might even do. I feel like it converges in less than 7 seconds. Anyway, okay, this is just for a given initial condition. And by the way, this is, let me just show that. Remember that, right? This is the nonlinear dynamical system. We compute its Lyapunov function in the previous lecture, right? In the previous video. And okay, so this is and this are equivalent, right? Okay, I just want to, put it in the comments to remind, okay? And this, wait a sec. Okay, let me control T, right? And again, first let me do this. First let me do this. And also let me do this and this, I guess, right? Okay, I'm just going to simulate this section, right? Okay, but there is some kind of a problem, I guess. Yeah, I forgot that. All right, and we have a really good, beautiful looking graph, right? Here, time's moving along that direction, right? And if you want to only see x2 of t, right, you will do basically something like this. And if you want to see x1, you would look from above, right? And this is it. And let me just show it to you. Okay, it starts from this location and converges to 0, 0, right? This is 0, wait a sec, 0, right, comma 0, basically. Okay, this is it. And let me just comment this and comment this and comment out this. and comment out this, right? And now I'm going to simulate something else. Okay, this is only for without the t direction, t axis, right? And again starts from this location and converges to the equilibrium point 0, 0, right? Okay, and this is basically, let's forget about this figure, or yeah, let's forget about the plot lines, right? It is, yeah, this is 5 lines of code, and maybe you might even do less than that, right? For example, this is totally unnecessary. I just put it out of, you know, habit. For example, in the given nonlinear dynamical system, you might have a parameter that you also like to show how the system would behave if that parameter ranges between 1 and 1.1, for example, right? For that type of studies, you will use that. Anyway, so I did it, I put it, but I didn't use it, is what I'm saying. Okay, just to show you how you will do that in that case. Okay, and I am just going to comment this out, right, in this manner. And okay, so all right, in the second section, second stage of this video, maybe I should start, you know, arranging some chapters in the videos. That will be helpful, I guess. Okay, and it says let us generate 100 random initial points in this state space, right? Okay, so this is the radius of our ball, right? 10, I said 10. And again, figure. Okay, we are just going to plot, right? This is only for, I mean, it may take a couple of seconds maybe. This is only for, let me just run that. What's that? Yeah, forget that. Yeah, this is only to draw this ball, right? In red line, right? Okay, this is our domain basically. And again, we picked 10 points. Actually, we might, yeah, I set 100 random points, but I draw 10. You know what? Let me just make it larger. All right, we are just going to sample 100 in this comment, right? 2 is the number of dimension. Here you can check that. Maybe let me just do it like this, right? And dimension, the state space dimension is 2. R1 is the radius, right? Radius. Endpoints, the endpoints, and the number of points that we sampled, right? All right, I'm just going to run this section, right? No, before that, so for example, let me just run this, right? Okay, what is our, right? Let me just, for example, first row, right? And all of the entries is this, and maybe, right? Okay, so this is xi basically in the, if you recall in the previous video, right? And this is some initial condition, and this is x1 component of that initial condition, and this is x2 component of that initial condition. So this is I for I equals 2, right? And dot dot dot, it raised like that. And I'm looking at this. Okay, I'm just, yeah, okay. So for okay, I iterates over the random points and does that, right? Just give me some initial, for example, when I equals 1, just give me this, right? And then again, these 3 lines are just same. I just copy it and paste it, right? Okay, here for t-span, right? And I'm looking at this, and yeah, we only change this because we want it to simulate given for that initial condition, right? All right, I'm just going to, okay, I equals 1 and compute it and plot it, and hold on, right? I equals to compute it and simulate it and plot it, right? Iterate like that. So let's go. All right, this is a beautiful plot, I should say. All right, so there are initial conditions, right? There are initial conditions, and all of them are inside our ball, right? And they all converge to the equilibrium point. Even, for example, I feel like this would be, or this should be, your first step in determining the stability question. And stability question is a important subject in a lot of cases, right? And this would be the first thing to do, right? Okay. Of course, for higher dimensional systems, you wouldn't be able to, for example, this is two-dimensional, and that's why we are able to see that. If it were three-dimensional, again, we would be able to see that. But if it were more than 3, right, we would choose, for example, let's say 10, right, 10, and we would just plot xi, no, x1, x2, dot, 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 x10 against t, right? We would generate 10 individual plots, and all of them, for example, for x1 t, we will just plot x1, I mean x1 component of every simulation, right? X1 component of every trajectory, I should say, right? Okay, this is maybe hopefully in the future videos I would focus on that kind of studies as well. All right, I'm just this is actually the purpose of this video, I should say, like the final stage. And all right, don't get confused. Okay, don't get confused. Just let me tell you, we just determined this in the previous video. This is all you need to know, okay? And don't focus on the numbers, don't focus on the terms even, right? We just found it, or somebody, let's say we we are really good on division of labor, right? Somebody, another engineer or something, just gave us this Lyapunov function, and we are just, maybe our job is to check whether the given Lyapunov function is valid or not, right? And after that, we just like almost copied and pasted, right? We just almost copied and pasted. Give me x1 and x2, right? Like give me Libert or something, right? Give me x1 and x2, and I'm going to give you that vx value, v of x, right? For that given x, right? And just don't get confused about term 1, term. There were like 8 terms, right? So I did each one of them like this. I just basically, to be honest with you, like, by the way, I just copied that from, literally copied that from the previous video, and I just, for example, paste it, right? And then in each term, I just highlighted that section and Ctrl C, right? And press that, and then after that, I just highlighted this section and I just put asterisk, right, to multiply that. So that was really, this is really advanced stuff, by the way. I won't say this, okay? And after that, let me just focus on this. Yeah, this is Lyapunov function. And by the way, maybe you don't use that type of strategy, but you can put functions inside of a script, but you need to put it at the end of the script, right? And for example, if I put it on top of, it would comprehend, I guess. All right, so this is all right, this is mesh grid. A lot of people are familiar with this, I guess. And this is contour plot, right? And okay, we just generated like many, we just created a rectangle, right, between -10 and 10, right? And we just discretize that rectangle, this area, and we have basically, for 100 times 100, right, 10,000 points in state space in the rectangle of -10 to 10, right? Okay, we just have that. By the way, let me recall something. Our domain of interest is inside that ball, right? But this is rectangle. So I mean, just keep that in mind, right? And for every given x1 component on x2 component, okay, just give me x1 and x2, and I'm going to give you the Lyapunov function value for that state space location, right? All right, and this is for 500 contour plots, to generate 500 contour plots, right? And this is a lot of, yeah, contours. And I'm looking at this. Yeah, the only problem that I would kind of get, that I didn't expect, I guess, just to figure out this dot, right? Usually, for example, this is like that, right? This is like that, but I just put it dot because the mesh grid function and contour, yeah, kind of requires that. All right. Okay, without further ado, let me just run that, right? Okay. Oh, it's really mesmerizing. Okay, let me make it bigger and enlarge it. Okay. Maybe even bigger. Okay, by the way, don't. This is some illusion. It's not like water drop or something. It's not like that. Maybe. Let me focus. Wait, one sec. I made a mistake. Get zoom in to that location. It feels like circle. Yeah, actually it is not, right? So this is kind of, yeah, that kind of thing you would see when if you generate DFT matrix and use an image function, you basically plot the matrix. You would see that type of, you know, you see, okay, that type of graphical illusions, I guess, visual illusions, right? So this is our v of x basically. This is x1 axis, this is x2 axis, and this is the contour lines basically indicates v upon a function. For example, this v of x equals 1, this is v of x equal 2 or something. I'm, you know, just exemplifying the concept. Okay, let me just comment out and let me just run this function. To be honest with you, I haven't used that function so far. This is new. Let me just run that, right? Wow, this is even cooler, I guess. All right. Okay, let me get that. Again, this is x1 axis, this is x2 axis, and this is v of x, right? Let me rotate that. All right. Okay. Again, we are able to see the contour plus, right? But I only wanted to see the contour plus, so I will be using contour function, right? And okay, now is the time for us to, you know, basically run the whole simulation. I feel like I should really document this. I mean, video itself is a document, but I feel like in every video I should add a link or something for you to be able to download these functions. I mean, you can just, I mean, otherwise it will be really annoying for you to, you know, we have to just written down all of those, right? Type in them. Okay, I'm just going to run, right? Let me run it. Okay. Yeah. Right. Didn't complain and gave us a really beautiful plot, right? Okay. By the way, you are like, hey, what are we even looking at, right? And first of all, the red line is the our domain of interest, right? This is just focus on this. I mean, just do not focus on this other regions, right? And after that, the other lines are like this colorful lines, I guess. They are simulations of the system, right? And for example, let me just make it like that. Yes, for example, let's focus on this line. It never, for example, touches this line, and after that the line or the contour line outside of that, right? it is here, and the only choice from that location is to get to here, right? And it is like gradient descent, right? It just descends, right, to that. Yeah, it never, it is, I mean, in a way, purpose of the Lyapunov function is to show this, right? It is like energy in a way, or metric of a solution, some would say, right? Some would with a really good mathematical background. And for example, this is, you may think of it as energy, and in that point, for example, can you see my cursor? I feel like you can. Okay, in that point we have, let's say, 10 unit of energy, right? And after that, and this contour line stands for 10 unit of energy, right? It signifies that, right? And after that, 9 point of energy, let's say, right? Or 9.9, let's say. And we are here, and we have 10 unit of energy, all right? And we will basically spend some energy, right? And get to a point 9.9, and after that the energy will only decrease, right? Okay, this is not valid for every system. This is valid for this system because convergence is something we study, and we see that the system converges to the equilibrium point in the ball, right? Okay, in every initial condition it converges to that. Okay, I just want to make that clear. So what I'm trying to say is, I'm going to repeat that one more time. Since the equilibrium, the convergence to equilibrium is, we just see that, right? We are here, for example. There will be no trajectory inside the ball, the red ball, right? Not red ball, the drink, right? The red ball or red circle, right? We are here, and you will never see a trajectory. If you see, that means you did something really wrong. Okay, we are here, and trajectory makes something like this, right? It never goes to that location. Go outside, right? Go outside of this. Go to this direction, right? It always goes to that direction. Okay, this is the whole story. And again, this is the plot. In contour lines, again, stands for or signifies v of x. For example, this contour line signifies v of x equals 1. For example, this one v signifies v of x equals 2. For example, right? It goes like this. All right. And one more time, this looks like, hey, is there a circle over there? What's going on? No, it's only a visual illusion. Let me just close. Okay, zoom in, and yeah, there's no circle here, right? There's no close contour over there. This is only a just big contour, right? And okay, this is it, I guess. Let me just check everything again. And yeah, I just get this from the MATLAB website. This is basically how you will generate 3D or contour plots, basically, right? Okay, and I'm looking at this. And by the way, another thing, when I use this, it gives me, for example, what I'm saying is this: I generated or computed rather my Lyapunov function, right, using 1000 points in state space inside of a ball, right? And after that, I just simulated the nonlinear dynamical system to see the convergence and to check its Lyapunov, check the Lyapunov function that we computed, its properties and such, right? And for other 1000 points that we later generated, so we haven't shown you basically the same points, the Lyapunov function's validity for the same random points, right? For example, I mean, even this only, even this is, for example, is enough, I guess, right? There are 10,000 points, and again, let me just do that. Yeah, for example, basically there are 10,000 points Lyapunov function, and we see that, and since we see, for example, this type of contour, even that kind of signifies, yeah, the Lyapunov function at least is positive. And after that, you would do, you would like to do the same thing for v dot as well, right? Okay, and v dot will look like the same, but the inner area will, or would probably look, or would be in yellow, right? Yellow, green, greenish, blue, and then blue over there, right? Okay, because it inside it increases, right? V dot, I mean, this is v, right? Okay, and that's all, folks, and thanks for watching.